we're going to look at something speeding up. Let's say that we've got a car. That car is accelerating from rest. Put a dot to represent its position every second. So it's here, and it's here. And as time goes on, with every second, the car covers more and more distance. So I can put some velocity arrows on here. The length of this arrow represents how fast the car is going, and the direction the arrow is pointing represents the direction the car is traveling. I can also put acceleration arrows. Because my velocity is increasing, my acceleration arrows are going to point in the same direction as my velocity arrows. The unit of acceleration is meters per second per second. We also call this meters per second squared. Acceleration tells us the rate of change of velocity. So if my acceleration of this car is 5 meters per second, that means the velocity of the car increases 5 meters per second every second the car is driving. So if this arrow represents 5 meters per second, I add 5 meters per second, and this arrow should represent 10 meters per second. Then I add another 5 meters per second, this would represent 20 meters per second. Now let's draw some graphs to represent the motion of this car. We'll start off with a position versus time graph. I'm going to set this as the positive direction. On our position versus time graph, we're starting at a velocity of 0, so we should start with a slope of 0. And as time goes on, our line becomes steeper. We know that the slope of a position versus time graph represents velocity. And we know that because to find our slope, we take change in position over change in time. Change in y over change in x. So our units are meters over seconds. The units on the x-axis are meters, the units on the time axis are seconds. Because the slope of our position versus time graph is velocity, we can draw a velocity versus time graph. Our slope here starts off at 0. You can use your pen as a slope indicator by holding your pen tangent to the curve. Remember that tangent means your pen will touch the curve in one place, and it shows the slope of the curve at that point. As time goes on, my pen becomes more and more positive. So we're going to start our velocity graph at 0. As time goes on, we get more and more positive. The slope of our velocity versus time graph represents acceleration. We know this because of the units. We have meters per second on the y-axis and seconds on the x-axis. So the units are meters per second, or meters per second squared. We can use this information to draw an acceleration versus time graph. The slope of my velocity versus time graph is constant and positive, so my acceleration graph will show constant positive. Now I'm going to switch things up just a little bit. This time, I'm going to say that the negative direction is to the right. And I'm going to redraw these graphs with the car moving in the negative direction. So I draw my position versus time graph, and I know that my car starts off at 0, and as time goes on, it gets faster in the negative direction. So I'm going to start with a slope of 0. As time goes on, the slope becomes negative. In my velocity versus time graph, I start with a 0 slope. As time goes on, my slope becomes negative, so I start at 0 and go to negative. Then I draw an acceleration versus time graph, and I have a negative slope here, so I'm going to have a negative acceleration. Notice a few things about this speeding up situation. On our velocity versus time graph, as time goes on, the line gets farther and farther from zero. Remember that this point right here represents zero velocity. Over here, same thing. This is zero velocity. As time goes on, the line gets farther and farther from zero. That tells us that it's speeding up. Up here, our slopes get steeper as time goes on. So when we have a steeper slope, we cover more position for every chunk of time. So if I have this little chunk of time here, we covered this much distance in that chunk of time. Or if I look at that same chunk of time down here, we just covered a little tiny bit of distance. When we look at our acceleration graph, we can't tell if we're speeding up or slowing down from just the acceleration graph. We also have to look at the velocity graph. When velocity and acceleration have the same sign, the object is speeding up. Here we have negative velocity and negative acceleration. Here we have positive velocity and positive acceleration. So when velocity and acceleration have the same sign, we know that we are speeding up. Now let's do a situation in which the car is slowing down. So we have our car again. This time, it's covering a lot of distance at the beginning, and as time goes on, those dots get closer together. I'll draw my velocity arrows again. The car is going in this direction. The lines start off long because the car is going fast in the beginning, and they end short. When I add my acceleration arrows, those arrows are going the opposite direction of velocity. So we talked about earlier, let's say that our acceleration this time is -5 meters per second per second. That tells us that our velocity is going to change by -5 meters per second every second. If we say to the right is positive, our velocity is starting off at positive. So let's say that this is 50 meters per second. After 1 second, the velocity is going to decrease by 5 meters per second. So this would be 45 meters per second, and so on. Let's draw some graphs to represent this motion. For a position versus time graph, where to the right is positive, we have a positive slope that goes to 0. So we're going to start off with a steep positive slope, and as time goes on, the slope goes to 0. Our velocity graph can be found by looking at the slope of our position graph. We start off with a steep slope. As time goes on, we go to 0. So positive to 0, so that looks like that. And our acceleration versus time graph has a negative slope. So we have negative on our acceleration versus time graph. Now let's switch it up. Let's say that this is now the negative direction. In that case, we're going to start with a high negative velocity. So we have a negative slope that's going to go to 0. So our graph will look like this. Our velocity graph will start negatively because we have a negative slope. As time goes on, it goes to 0. And our acceleration graph shows the slope of the velocity graph, which has a positive slope, so it will look like this. Notice again that our velocity graph shows that we're slowing down because this is 0 velocity. As time goes on, this line approaches 0. Here, we're slowing down because as time goes on, this line approaches 0 velocity. Our position versus time graphs show a shallower slope as time goes on. So we start steep, and as time goes on, the steepness decreases. So that shows slowing down. Once again, we can't tell if it's slowing down from the acceleration versus time graphs alone. We have to also look at the velocity versus time graphs. Notice here that we have positive velocity here, negative acceleration here. On this one, we have negative velocity and positive acceleration. So in this case, velocity and acceleration have opposite signs. So that means that we are slowing down.